Hey guys, welcome back to another video. Today I'm going to be getting some work done for my startup. I just got to the library. It's about 6 p.m. The reason I decided to work from the library today is because I just wanted a change in scenery. I work from home today as a software engineering intern, and I really just wanted to get out of the house since I have more work to do right now for my startup, and I figured I'd take you guys with me. Also, I am using a new camera now, and I finally have a quality mic, so hopefully the quality of the videos goes up from here. Our startup currently uses Vercel to host our Next.js project, which runs on a Node.js backend. Vercel is great when you're starting out because it makes deploying an MVP super simple, which is exactly why we chose it. When you follow lean startup methodology, your goal is to deliver an MVP as fast as possible so you can learn from your users and iterate quickly. But here's the limitation. Vercel runs on serverless infrastructure. It uses AWS Lambda functions under the hood. While serverless is awesome for a lot of use cases, it has some key constraints. You deal with cold starts, limited execution time, limited CPU and memory, and most importantly for us, no built-in support for persistent WebSocket connections or long-running background tasks. And this is exactly where we ran into a problem. We want to build a live chat messaging feature so that students can message different clubs directly. To do this, we need WebSockets, which requires a constant and persistent connection between the client and server. This simply isn't possible with Vercel and AWS Lambda alone. So we needed to spin up our own AWS EC2 instance that will handle WebSocket connections and the messaging logic. This is also the first of many microservices that we plan to add to our architecture. But how do WebSockets actually work? They don't just stay open magically. First, there's something called a handshake, which upgrades a regular HTTP request to a WebSocket connection. Once the handshake is complete, the connection stays open, allowing for a real-time, bidirectional communication between the client and the server. This is exactly what we need for our chat feature. Now, using an EC2 instance means that we need to manage and maintain a second server on top of our current Vercel deployment. An EC2 instance is basically a virtual machine, which is a computer running in an AWS data center. The cool part is how customizable it is. You can choose how many CPUs, how much memory, and what operating system you want to run. When setting up the instance, one of the first things I had to handle was secure access. AWS provides a key pair file, which acts as your private key for SSH access. You use this key to securely log into your server from the terminal. After that, I configured my security groups, which are basically firewalls, to allow only certain ports to have access to your server. I also plan to Dockerize this microservice for consistency. Docker ensures that the app runs the exact same way across different environments, whether that's development, staging, or production. It also makes deploying updates easier, managing dependencies simpler, and scaling the service with tools like Docker Compose, ECS, or Kubernetes more straightforward. And of course, it helps avoid the classic "it works on my machine" problem. Even though this is just our first microservice, containerizing it will allow us to save a lot of headaches later. That's it for today's video. Hopefully you guys found it interesting. If you have any questions about AWS, EC2, or microservices, feel free to drop them in the comments down below. If you enjoyed this video, don't forget to drop a like and subscribe to the channel. I'll be sharing more behind the scenes updates as we build the rest of our product. See you guys in the next one.